In this example problem, we'll use molecular orbital theory to examine the bond order, bond strength, and magnetic properties of different molecules. The problem reads, use molecular orbital theory to determine A, the bond order of N2, B, whether N2 is paramagnetic or diamagnetic, and C, order of increasing bond strength for N2, N2 and N2 First, we'll calculate the bond order of N2 by creating a molecular orbital diagram. To create the molecular orbital diagram, we'll start with the orbital diagram for both nitrogen atoms, focusing on the valence electrons. The 2s atomic orbitals of both of our nitrogen atoms will combine to create two molecular orbitals. These molecular orbitals are the sigma 2s orbitals, bonding and antibonding. The antibonding orbital is higher in energy, and the bonding orbital is lower in energy than the 2s atomic orbitals of nitrogen. The antibonding orbital is indicated with the asterisk. Next, we'll combine the three 2p orbitals of both of our nitrogen atoms to create 6 new molecular orbitals. When the p orbitals combine, they create both sigma and pi molecular orbitals. The correct order of lowest energy to highest energy orbitals are shown here and are determined computationally. Now we'll fill our molecular orbitals. We'll start by using the 4 electrons in the 2s orbitals of both nitrogen atoms. These electrons will fill the bonding and antibonding sigma 2s molecular orbitals. Next, we'll use the 6 electrons from the 2p orbitals of both nitrogen atoms. Those 6 electrons will occupy the lowest available molecular orbitals, which are the pi 2p and sigma 2p molecular orbitals. To calculate bond order, we'll take the number of electrons in bonding orbitals, subtract the number of electrons in antibonding orbitals, and divide that quantity by 2. In our N2 molecule, we have 8 electrons in bonding orbitals, and we have 2 electrons in antibonding orbitals. So 8 minus 2 is 6, divided by 2 is equal to 3. Part C, we want to find the order of increasing bond strength for N2, N2 and N2 Bond strength increases with increasing bond order, so we'll want to determine the bond order of all 3. The charge of N2 means we have 2 additional electrons to place in our molecular orbitals. This gives us a total of 12 electrons. So we can fill our molecular orbitals with those 12 electrons. Then to calculate the bond order, we'll take the number of electrons in bonding orbitals, subtract the number of electrons in antibonding orbitals, divided by 2. We still have 8 electrons in our bonding orbitals, but now we have 4 electrons in our antibonding orbitals. So we have 8 subtract 4 divided by 2, which will equal 2.